Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2014 problem from ordinary differential equation. Here in the question, solve the following differential equation. Differential equation is given by when e to the power x is a solution to its corresponding homogeneous differential equation. Let's solve the problem. Given differential equation is, this is given by x into d2y upon dx2 minus of 2 into x plus of 1 into dy upon dx plus of x plus of 2 into y is equal to x minus of 2 into e to the power x. Given differential equation, dividing both the side with x, this gives d2y upon dx2 minus of 2 upon x into x plus of 1 into dy upon dx plus of x plus of 2 into y upon x is equal to x minus of 2 into e to the power x upon x. And this is the differential equation, and we have to here in the given question, if y e to the power x is a solution to its corresponding homogeneous equation, taking y is equal to v into e to the power x is the another solution. We have to let this differential equation is equation 1, and differentiating y is equal to v into e to the power x and differentiating with respect to x, this gives dy upon dx, and here v is taking first function and e to the power x is the second function. We have to differentiating, this gives v into e to the power x plus of e to the power x into dv upon dx, and from here we have to take common e to the power x. This gives v plus of dv upon dx, and again dy upon dx differentiating with respect to x, this gives d2y upon dx2, and again we have to taking here v is the first function and e to the power x is the second function, and here e to the power x is the second function and dv upon dx is the second function. First we have to solve for this. This gives v into e to the power x plus of e to the power x dv upon dx, and again we have to differentiating this part. This is given by e to the power of x, differentiating dv upon dx with respect to x, this gives d2v upon dx square plus of dv upon dx, and again differentiating e to the power x with respect to x, this gives e to the power x, and from here we have to take common e to the power x d2y upon dx2, and e to the power x is taking common, this gives v plus of dv upon dx and plus of d2v upon dx square and plus of dv upon dx, and we can also write this is d2y upon dx2 is equal to e to the power x into here d2v upon dx square is taking first and plus of dv upon dx and dv upon dx, this gives 2 dv upon dx and plus of v. We have to put the value of dy by dx and d2y upon dx2 in the differential equation of 1. So we have to put here, this is given by place of d2y upon dx2, we have to put this is e to the power of x into here d2v upon dx2 and plus of 2 dv upon dx and plus of v, and here minus of 2 upon x into x plus of 1, and again we have to put the value of dy by dx. This is given by the value of dy by dx is given by e to the power of x into v plus of dv upon dx, and here plus of x plus of 2 upon x, and we have to put the value of y also. Y is equal to, we have to taking v into e to the power x, so we have to write here v into e to the power x is equal to here x minus of 2 upon x into e की power x. And take from left hand side we have to take a common e की power x. Once again, taking e की power x common from left hand side, this gives e की power x is taking common. Here is d2v upon dx2 and plus of 2dv upon dx and plus of v, and from here this is given by minus of 2 upon x into x plus of 1 multiplied with v plus dv upon dx. This gives minus of 2 upon x, x plus of 1 into v, and minus of 2 upon x into x plus of 1 into dv upon dx. And here this is x plus of 2 upon x into v, and here is equal to, once again we have to take in bracket here, on equal to this is given by x minus of 2 upon x into e की power x, and from here we have 2 e की power x, 2 e की power x is cancelled out, and the remaining we have to simplify these terms. This is given by d2v upon dx2, and we have to solving from here, taking first 2 dv upon dx and minus of 2 upon x into x plus of 1 dv upon dx in one bracket, taking plus of 2 dv upon dx is taking common here, remaining is 1, and here is once again here is minus of x plus of 1 upon x. We have to take a common 2 dv upon dx, then remaining is minus of x plus 1 upon x, and further we have to take plus of v and minus of 2 upon x into x plus of 1 into v, and plus of x plus 2 upon x into v in one bracket. This is given by once again plus of v and minus of 2 upon x, x plus of 1. We have to take a common v here. Taking v is common, this is given by, here is 1 minus of 2 upon x into x plus of 1, and from here we have to write x plus of 2 upon x is equal to x minus of 2 upon x. When we have to solve here, this gives d2v upon dx2 plus of 2 dv upon dx. When we have to solve here, this gives x minus of, minus multiply with this bracket, this gives minus and minus of 1 upon x, and from here plus of x and minus of x is cancelled out, and plus of v, and we have to taking LCM is also here, this is LCM is x, and this is given by x minus of, taking open bracket, this is minus of 2x and minus of 2, and here is plus of x and plus of 2 is equal to x minus of 2 upon x. When we have to solve here, this is plus of 2 and minus of 2 is cancelled out, and plus of x and plus of x, this is plus of 2x and minus of 2x is also cancelled out, and these parts becomes 0, and the remaining is here, this is d2v upon dx2, and here minus of 1 upon x multiplied with 2 dv upon dx. This is written as minus of 2 upon x dv upon dx, and this part becomes 0 is equal to x minus of 2 upon x. And further we have to simplify. Further we have to simplify, taking dv upon dx is equal to p, and we have to put here in place of dv upon dx, we have to put p. This gives dp upon dx minus of 2 by x into p is equal to x minus of 2 upon x, and this is a linear in p, which is linear in p. This is the linear form of differential equation, in P form. And we have to find integrating factor first. And integrating factor is given by e to the power of p dx. The coefficient is here minus of 2 upon x into dx, and we have to solving here. This gives e to the power of dx upon x is log x. This gives minus of 2 log x, and with the property of log we can also write this is e to the power of log x to the power of minus 2, and from here this is given by x to the power of minus 2, and we can also write 1 upon x square. This is the integrating factor, and we have to find the solution of the linear differential equation here. This is given by linear in P, so we have to write here P into y into if. P into integrating factor, this is given by 1 upon x square is equal to integration of q into if. Here q is x minus of 2 upon x into integrating factor is 1 upon x square into dx, and we can also write here this is integration of x minus of 2 upon x cube onto dx, and we have to break in the partial form. We can also write this is integral of 1, we have to break, this is written as 1 upon x square and minus of 2 upon x cube into dx. When we have to take LCM, this is x cube and here is x is not present, so we have to multiply with x minus of 2. This is a correct partial different. We have to break in the partial form and integrating separately. This gives integration of dx upon x square and minus 2 integral of dx upon x cube. We have to integrating. We can also write in the form of, once again, we can also write in the form of, this is written as p upon x square is equal to, here we have to take 1 upon x square into numerator. This gives integral of x to the power of minus 2 into dx and minus 2 integral of x 1 upon x cube is taken to the numerator. This gives x to the power of minus 3 dx, and we have to use the formula. This is given by x to the power of n, dx is given by x n plus 1 upon n plus of 1. So we have to use here, this is given by x to the power minus 2 plus of 1 and minus 2 plus of 1, and here is minus of 2 into, on integration of minus x to the power minus 3 dx is written as x to the power minus 3 plus of 1 upon minus 3 plus of 1, and here we have to take our integrating constant. This is c1, and further we have to solve. This is written as x to the power minus 2 plus 1 is x to the power minus 1, x to the power minus 1, and here minus 2 plus 1 is minus 1. This is minus 1, and from here this is given by minus of 2 into x to the power minus 3 plus 1 is x to the power minus 2, x to the power minus 2 upon here minus 3 plus 1 is minus 2 and plus of c1. From here 2 to 2 is cancelled out and minus minus is plus, so we have to write here p upon x square is equal to, here is x to the power minus 1 is taken to denominator. This gives minus of 1 upon x, and here minus minus is plus and x to the power minus 2 is taken to denominator. This gives plus of 1 upon x square and plus of c1, and we can also, so once again we can also solve for this. This is written as p upon x square is equal to, we have to multiply x square, cross multiplication with this gives p is equal to minus of 1 upon x into x square and plus of 1 upon x square into x square and plus of c1 into x square. And from here x square to x square is cancelled out and x to x square is cancelled out, remaining is x. This gives p is equal to minus of x plus of 1 plus of c1 into x square. And we have to earlier let dv upon dx is p, and so we have to put here in place of p, this is dv upon dx. Once again we have to put in place of p, this is dv upon dx. This is minus of x plus of 1 plus of c1 into x square, and we can separately integrating, this is dv is equal to minus of x dx and plus of dx and plus of c1 into x square dx. On integration this gives, once again we have to integrating, on integration of dv is v and minus of x dx, this gives x square upon 2 and dx on integration, this gives x, and here plus of c1 and integration of x square dx is written as x cube upon 3, and taking again second integrating constant, this is c2, and this is the value of v1, and we have to write final solution of equation 1. We have to earlier let y is equal to v into e to power x, and we have to put here the value of v is here, this is given by minus of x square upon 2, minus of x square upon 2 and plus of x and plus of c1 into x cube upon 3 and plus of c2 into e to power x, and we have to multiply in each part, we get the final solution. This is given by minus x square upon 2 into e to power x and plus of x into e to power x, and here plus of c1 into x cube upon 3 into e to power x plus of c2 into e to power x. This is the required solution of the given problem. Thank you class, and thank you for watching. UPSC asked in 2014 for 15 marks.